Let's continue building our invoice processing automation by adding some business logic to enforce our corporate financial policies. We built an integration that creates the invoice, but our business has additional finance policies we must enforce. For example, we might want to validate that the invoice amount matches the purchase order amount. We'll do this by building an RPA robot and decision, and then orchestrate them within the Create Invoice integration. A robot gets the PO amount from a legacy purchasing system that doesn't have APIs. A decision compares the invoice amount to the PO amount and determines if the data complies with the policy. We'll start by building a robot. The robot demo illustrates several use cases and critical capabilities. Here are the top 3 takeaways. RPA is a built-in capability within an OIC project. Robots can be built and managed within the same context as other automation solution components. You don't need to install a specialized development studio. Instead, build a robot in an OIC project using our easy-to-use recorder or powerful low-code components. These tools allow for easy builds and simple maintenance. Finally, collaboration is improved for RPA centers of excellence and business IT teams, thanks to the combination of building robots within a broader automation solution and providing simple tooling to create robots. A business technologist builds a robot using our new RPA capabilities. We'll call our robot Get PO Details. We'll pass the robot the PO number associated with the invoice, and the robot will find and retrieve the purchase order information. We'll use our RPA smart recording technology, which makes it simple for business technologists to build robots. We already have a pool of computers called an environment pool that the robot can run on, as well as a robot connection to Oracle ERP Cloud. Robot connections are similar to integration connections. They both externalize endpoint and security configurations, making it easy to move a robot from test to production. A robot connection typically includes the web app URL, username, and password. We add a robot. This demo shows a split screen of Oracle integration and the purchasing system. We define a trigger, which specifies the robot interface. We specify the input. In this case, it's the PO number coming from our invoice. And the output is the PO amount from the retrieved PO. We start the recorder and train the robot to open the Oracle ERP Cloud Web App and sign in. We use the URL, username, and password from the robot connection, which we already created. Now that we're signed in, we can train the robot to navigate to the correct page. The business technologist follows their regular workflow while recording, and Oracle integration builds the robot automatically. The feedback that we've received from early adopters has been phenomenal. To help users get the robot right the first time, we engage them in the recording experience. For example, we separate robot configuration from the data used in the recording, such as using a specific PO number during the recording, but configuring the robot to use the PO number passed in the input. Additionally, we support overriding default actions, such as replacing a click element action with a getText action. Engaging users immediately during the recording makes it easier to fine-tune the robot and eliminates the need to go back and retrofit code. As you've seen, business technologists can build a time-saving robot in minutes, and refining a robot is just as fast and easy. Next, we add a log action so we can view the PO amount returned in the runtime activity stream. At any time, we can fine-tune an action that we created while recording. For instance, capturing a screenshot before or after an action occurs can help with troubleshooting a robot. We can also edit or add to the validation that is automatically generated during the recording. Robots, by their nature, are prone to issues if disruptive changes occur in an application's user interface. The auto-generated validations identify runtime errors at the point of failure and also provide an easy-to-understand description of the potential issue. Another feature we've added to simplify robot maintenance is the globalization of all user interface element targets. This allows us to reuse targets, such as when a user interface element is used multiple times in a robot flow. Globalized targets also eliminate the need to scour code looking for broken targets. Instead, a developer can simply look up a broken target and correct it for all uses of the target throughout a robot flow. Save your changes at any time, and Oracle integration validates everything that you've built. Our robot is now finished. It's time to add the computer, which we call an environment, where the robot runs. And then associate the environment pool with the robot. Users can add multiple environments to an environment pool to satisfy workload requirements. Oracle integration automatically load balances workloads across the environment pool and alerts users when the environments are insufficient for the workload demand. We activate the robot. And now it's time to test the robot so we can see it in action. Our testing interface allows us to specify the robot input, which is a sample PO number. The robot opens the purchasing system, searches for the PO, and gets the PO amount. We can view the PO amount in the activity stream, but we'll save that for later when we dive deeper into observability. We're finished building the robot, so let's do a quick recap. We illustrated several use cases and critical capabilities. The key takeaways are that RPA is a built-in capability in an OYC project. You build robots in the OYC project browser interface without needing to install a specialized development studio. Finally, incorporating robots within a broader automation solution and providing simple tooling facilitates collaboration between teams. Next, we need to build a decision to model our corporate financial policies. A business technologist creates a decision to specify the implementation details for a policy. The enforcement of these policies is separate and occurs in an integration orchestration or process workflow. This separation provides several benefits. It promotes reuse. Additionally, separation allows policies to be defined and managed by policy specialists rather than teams with more technical skill sets. Finally, separation means that changes to policy details are easy and non-disruptive to the rest of an automation solution. Oracle decisions can be used to model highly complex business logic. But for this demo, we'll create a very simple decision that compares the invoice amount and PO amount. This demo illustrates several use cases and critical capabilities. Here are the top 3 takeaways. First, decisions are reusable. After you build a decision, you can use it from within an integration, a process workflow, or any application. Second, decisions foster efficiency. The policymaker doesn't have to rely upon an integration specialist. They can build and maintain their own policies. And finally, businesses can change policies quickly without disrupting the rest of an automation solution. That's because you can change policy details independently from the components that use a decision. Oracle integration provides the business technologist with a straightforward user interface for building a decision. Decisions are built and managed in an OYC project within the same context as other automation solution components. We create a new decision named AP policy and define its inputs. The invoice amount comes from the invoice event, and the PO amount comes from the getPODetails robot. Soon, we'll have the create invoice integration call this decision and pass these values. The logic is a simple if-then-else rule. If the invoice amount equals the PO amount, the decision returns true. If they don't match, it returns false. Of course, decisions can include additional constructs to model complex rules. For example, use a decision table to model all the possible conditions and results of a problem, or create a context to document all decision logic related to a particular scenario. Next, we create a service endpoint, which can contain a specific view and scope of a more complex decision model. If we had created more complex logic with multiple decisions, we could create multiple decision services with different views of the overall model. Time to test the decision model. When the values match, the decision service returns true, indicating that the policy is validated. When the values don't match, the decision service returns false. We're finished building the decision service, so you know what that means. A recap. We illustrated several use cases and critical capabilities. The key takeaways are the reusability of decision services across an organization, the efficiency of policymakers building and maintaining decision services independently, and the ability to make fast policy changes without disrupting the rest of an automation solution. We've created a variety of automation components for our solution. We get the PO data we need using an RPA robot, and we model our corporate financial policies using a decision. Now, we need to update the integration. Our integration specialist can update the Create Invoice Integration Orchestration to include these components. This part of the demo illustrates several use cases and critical capabilities. Here are the top 3 takeaways. Oracle integration includes a portfolio of automation technologies suited for specific technical challenges, such as robots and decisions. Incorporating all of these automation components in a unified OIC project workspace simplifies management and governance and makes the best use of existing skill sets. Encapsulating automation components within an integration makes it easy to swap components without affecting consumers of the integration. For example, a robot can be used today to automate interacting with an application and later be replaced in a new version of the integration if a more robust and scalable API becomes available. An integration orchestrates connectivity and automation components into a composite service, regardless of the solution's complexity. The first step is to invoke our robot. Oracle integration has a native activity to discover and invoke robots local to the project or shared to the project developer. We again map the data from the invoice event, but this time we map it to the robot. We've already seen the mapper, so we'll skip past the details. Now we add our decision. Again, Oracle integration has a native activity to discover and invoke decisions local to the project or shared to the project developer. And back to the mapper. We know that Oracle ERP Cloud applies formatting to one of the values we need, PO amount. We can use the replace function to remove the comma from the value before we map it to the PO amount in our decision service. Next, we add a switch statement to tell our integration what to do based on the value returned by the decision. To define our first path, we grab our decision output, called the interpretation, and configure this route for a true value. And we'll want to move our ERP Cloud Create Invoice activity into this route using our convenient cut and paste feature. Of course, we'll want to handle the case where the decision is not valid, so we'll add an otherwise route as a placeholder for now. This exception can be handled in whatever way we need using connections or any of our built-in integration activities. For example, sending a mail notification or initiating a human-in-the-loop process. And speaking of integration activities, we have a complete palette of advanced orchestration flow control constructs, activities to process files, error handling, and our vast portfolio of native OCI services, such as OCI AI services, including document understanding, language, vision, speech and Gen AI, object storage, functions, and streams and databases. Pretty much anything one can imagine can be built as an integration orchestration. Before we finish with our integration updates, maybe we should add a description. A complex integration design can be difficult to understand just by looking at it. An integration description can help, but creating a concise description can take a bit of time and be tricky. With AI-generated descriptions, one click does it for you. Recap time. We illustrated several use cases and critical capabilities. The key takeaways are: Oracle integration includes a portfolio of automation technologies suited for specific technical challenges. Encapsulating automation components within an integration makes it easy to swap components without affecting consumers of the integration. An integration is used to orchestrate connectivity and automation components into a composite service, regardless of the solution's complexity.